Welcome. So we're going to go back over some exponent rules because it was crazy with the interim last week and things like that. So two of the exponent rules that we know for sure. Product of a power. So if I have x to some power times x or any other number for that matter to another power, what I'm doing is adding them together. Okay, so that's pretty simple. An example would be 2x to the second power times 3x. Now on, I guess it was Friday, we broke this down a little bit more, right? So if you want to do this, break apart each individual term to show what's actually happening with the terms. So this is 2 times x over here, because there are two x's there, and that's what this is broken down to in its individual pieces. Then this is times 3 times x again. So I'm just going to put them all back together. Now I know you're asking yourself, well, why am I even breaking apart? Good question. You don't have to, right? You can use the rules to help you, but if this makes it a better representation, that's totally fine with me. So you're going to multiply the outer numbers together, or any numbers together. So this is going to be 6, and there are 3 x's here, so this is 6x to the third. Done. Going back to just this part of it, if I'm going to multiply these two terms together, I'm really adding the exponents, and that's a 1 there. So I would just go ahead and say 6x to the third here. But if you like this representation better, do it. By all means. Whatever you need to do. Let's do another one. 3b to the second power times 2b to the third power. Okay, give yourself a second, see if you can get that one. I'm going to break it down right now, though, for you. So this is 3 times b times 2 times b times b times b. Okay, that's what it says. So there are 5 b's there, right? And then 3 times 2 again would be 6. So this is 6b to the fifth power. Not too bad. That's the product of powers rule right there. So add them. Second rule that we talked about was the quotient rule, so the dividing. So if I have some variable or some number to the mth power, mth, that's weird, x to the m over x to the n, I'm really subtracting the exponents. Not so bad. An example of that would be, let's just take n to the third power divided by n. Well, again, if you want to break these down to its individual pieces, that will help. Okay. So there are 3 n's on the top, and there's just 1 on the bottom. So dividing, if I divide something by that same something, it's just 1. So I can just cancel those 2 out, right? And I'm going to be left with n squared. Or, if you wanted to use the rule itself, this is n to the third divided by n to the first. Remember, I'm subtracting those, I still get n squared. Okay? Not too bad, not too bad, not too bad. Let's try one that's a little more difficult. So, what if I gave you k over 2k to the 0? Let's break it down. Okay, so this really says 1k over 2 times 1. Because anything to the 0 power is 1. Now remember, this 2 and this k to the 0 power, they're completely separate things. I'm going to break it down to its individual pieces. Individual pieces, this is k over 2. Done. Okay, now if you wanted to do this and use the rule, k to the first, and this is just be 1, right? So k to the first divided by k to the 0. I'm subtracting the exponents. It's still k to the first, but the k to the first belongs on the top, right? And 1 divided by 2, well, I could just still write this. These two things say the same exact thing, but this is where I want to go. I don't want to go any further with that. Okay? Good. Awesome. Very cool. Now, the next rule, we talked about a couple more rules, but this is one we left out on purpose. The third rule, which is probably the one of the more important ones, is its power of a product. So if I have something going on in here, and there's parentheses, I think you remember me saying that. If I say that there's parentheses and then there is an exponent outside, what's happening is that exponent outside has to be distributed to every single term that's inside. So remember, parentheses you distribute anyway. I'm distributing that to everything on the inside. So let's try one. What if I gave you 2x to the third to the second? Okay, now that 2 has to distribute to everything inside. So let's break this down a little bit more. This really says 2 squared times x to the third squared. Okay, the 2 is going to distribute to everything on the inside. This is actually going to be 4 times x, and here's the thing. When there's a parentheses that separate an exponent from another exponent, you're multiplying those exponents. Okay, so that's a really big deal. So this has ended up being 4x to the sixth. Okay, no more adding here because I'm actually going to be multiplying these two things from the outside. It's much different than this. Here there is no parentheses. Here there's a lot of parentheses things going on, right? So you need to do something different. And what we're doing with the exponents is multiplying them. Let's try another one. Okay. 7x to the third, and then on the outside there's a second. Remember, I'm distributing this 2 to everything on the inside. There's two things in here. So 7 squared is 49, and x to the third squared is x to the sixth again, because I'm going to multiply those two things. That's my final answer right there. Breaking it down, this is 7 times x to the third, but it's 7 squared times x to the third squared. And then you can see how I simply get that. Okay? Not too bad. We'll do one more. And then I'm going to give you your answers to the problems that we tried. Or problems that you tried on your fever form. 2v to the 0 power to the 5th power. Okay, give yourself a second to try to figure that one out. Did you say 32? That's correct. Yes, it's 32. There's no variable. Because look, v to the 0 power, anything to the 0 power is 1. So this really says 2 times 1 to the 5th power, or just 2 to the 5th power, which is 32. Nice job. All right, let's go with some answers for the fever form. Number 1, hopefully you tried it first before I'm giving you the answers, because I need to see some work, right? Because that's how you get credit. Exactly. Number 1 is 6 to the 3rd power. Number 2 is 1 over x to the 8th power. Remember that negative exponent's a big deal. And then the last one, oh, it's crazy. The last one is 25 over 9. Okay, I'm gonna talk to you about that one a little bit. Number 3 was weird. Right? Number 3 should have been a fraction, which it didn't really look like a fraction, I don't think, to a negative power. I think I wrote in there, take your steps, right? So this really means, and just take it step by step, don't try to solve it at once. This really means 1 over 3 over 5 to the second. Remember, that's what that negative exponent means. So that's a good first step. If I'm squaring this fraction, I'm really squaring the numerator and the denominator separately, right? So this is going to turn into 1 over 9 to the 25th power, okay? Now, I'm not going to go any further with you because I want you to do this in the last step on your own. I want you not to write it as a double fraction here because I know that's freaky, right? It's weird. Write it out from like horizontally, left to right. Remember last year when you learned what happens when you divide a number by a fraction? What do you actually do with that? So try to focus that out and see how you would get the final answer of 25 over 9. The answer is 25 over 9. See if you can get it done. 8-minute video. Hope you enjoyed it. I certainly did, right? But I always do because math is awesome. I'm going to keep it under 8 minutes. Bye-bye.